How do you want to prepare for the battle against Megatron?
I think we should do optimization problems.
Why do you think we should do optimization problems?
It's gonna help us win.
Why do you think it's gonna help us win?
If we do optimization, we can win the battle in a fast and efficient way. Then we can get money.
Find two positive numbers whose sum is 300 and whose product is a maximum. The first step is to find an equation that relates both of the variables. Here from the question we can see that x plus y equals 300. We can manipulate this equation to be y equals 300 minus x, and we can use this newly found equation to put our optimization equation, which is the product equals x times y, in terms of one variable. When we do this, we can see that the product equals x times 300 minus x, or simplified, 300x minus x squared. We can take the derivative of this equation and set it equal to 0 to see that p prime equals 0 and x equals 150. Since we want to find the maximum, we want to find points where p prime goes from positive to negative. If we make a sign chart, we can see that p prime does indeed go from positive to negative at x equals 150. We now know that x equals 150, and using our original equations, we can find that y equals 300 minus 150, which is also 150. So the answer to our problem is x equals 150 and y equals 150. An apartment has 250 apartments to rent. If they rent x apartments, then their monthly profit in dollars is given by the equation p of x equals negative 8x squared plus 3200x minus 80,000. How many apartments should they rent in order to maximize their profit? So the first thing we have to do is establish constraints for our equation, which by looking at the question here, we can see that x has to be less than or equal to 250. The next step is to take the derivative of our equation, which is already given to us. So we can see that p prime of x equals negative 16x plus 3200x. We set p prime of x equal to 0, and we can see that p prime of x equals 0 and x equals 200. Making a sign chart, we can see that x equals 200 is a point where p prime of x goes from positive to negative, which means that this is a maximum. And since we are trying to find the maximization of their profit, this point works for us. So, x equals 200. So the final answer to our question is, the hotel should rent 200 of their 250 apartments in order to maximize their profit.
A small sticker company, Y, comes out with a new design for the letter L and finds that it can sell 1,400 L's at $15 an L. It also finds that for every 50 cents it drops the price, it can sell 100 more L's. What price should they sell the L's to maximize their revenue? Okay, so to first begin this problem, we first have the equation of 1,400, the initial amount of L's, plus 100x, which is the amount of L's they sell with a price drop, times 15, the initial price, minus 0.5x, which is the 50-cent decrease, which simplifies down to 21,000 plus 800x minus 50x squared. After that, we take the derivative of this function, and we get 800 minus 100x, and then we set that derivative equal to 0 to solve for the critical points, which we get a critical point at x equals 8. And then after that, we put it on the sign chart, which we get a positive initially, and then a negative after the 8, and that tells us that that would be a relative maximum. And after that, we plug it into our new price function, which would be this function we found out already. We plug in 8, and we get the new price of 11. So our conclusion is the sticker company should sell their L's for $11 in order to maximize their revenue.
Two poles, one 6 meters tall and one 15 meters tall, are 20 meters apart. The wire is attached to the top of each pole and is also staked to the ground somewhere between the two poles. Where should the wire be staked so the minimum amount of wire is used? So first begins problem. We've set up a diagram with the 20 meters of height distance and then the two triangles which are created, which is from the 6 meter pole and the 15 meter pole. And then we've given one of the legs as x and another one of the legs as 20 minus x. And to solve for the minimum distance, we first need to find the hypotenuse, which we label here as L1 and L2. So to find the hypotenuse, we use the Pythagorean theorem, which gives us L1 as square root of 36 plus x squared, and then L2 would be square root of 15 squared plus 20 minus x squared, which is simplifies down to square root of 625 minus 40x plus x squared. And then to find out the minimum distance, we need to add these two legs together, which is our actual equation, which is L of x, which is equal to square root of 36 plus x squared plus square root of 625 minus 40x plus x squared. And after that, we take the derivative, which is shown down here. And then after that, we simplify down this derivative down to x over square root of 36 plus x squared plus x minus 20 divided by square root of 625 minus 40x plus x squared. And after that, we take the derivative and set it equal to 0 to find the minimum values or critical points. And once we find the critical points using our graphing calculator, which would be the easiest and fastest way to do so, we get the critical point being 40 over 7. And we test the left endpoint, which would be negative, and then the right endpoint would be positive, so that would be a relative minimum. And then after that, we can assure that 40 over 7 would be the minimum value needed amount of wire used to find the optimum point, which given here, the wire should be staked at 40 over 7 meters away from the left pole in order to minimize the amount of wire used. Thank you.
What is the area of the largest rectangle with its sides parallel to the x and y axes that can be inscribed in the ellipse x squared over 16 plus y squared over 9 equals 1? Okay, let's start by making a drawing. So we have an ellipse that matches the formula, and we have this unknown rectangle. I just put coordinates xy, negative xy, negative x, negative y, and x, negative y. So we know that we can first solve for y. So y equals positive negative 3 times the square root of 1 minus x squared over 16. The area of the rectangle, we found 2x times 2y equals 4xy. The reason we have 2x is because from here to this point is x, and this is negative x. So negative x, and then x, that's 2x, and then this would be 2y, same case. So that's 4xy. And then we can substitute this y into that formula. So we get the area of the rectangle to be 4x times 3 times the square root of 1 minus x squared over 16. And we can simplify that down to 12x times the square root of 1 minus x squared over 16. So let's just define this function, f of x, and that is the area of the rectangle squared, okay? The reason why we squared this is so that we don't have to deal with a square root when taking the derivative. So this is just 144x squared times 1 minus x squared over 16, which just simplifies down to 144x squared minus 9x to the fourth. And then we take the derivative. So f prime of x equals 288x minus 36x cubed, or 36x times 8 minus x squared. So then we get critical points of x equals 0 and x equals positive negative 8. The reason why we can use f of x instead of as in place of the area of the rectangle this formula is because when the derivative of this equals 0, the derivative of this will also equal 0, because 0 squared is just 0, so it won't be changing. The only thing that will be changing is actual points where the y is not equal to 0. Okay, so then we can just draw a sign chart. So we have f prime of x and f of x. So at root 8, we see there's a relative maximum, because between 0 and root 8, f prime of x is positive, and between root 8 and 4, f prime of x is negative. So then we can plug in root 8 into y. So y equals 3 times the square root of 1 minus root 8 squared over 16. So we end up getting 3 root 2 over 2. And then the area of the rectangle would be 4 times xy. X is negative root 8, and y is 3 root 2 over 2. And when we solve that out, it's 24. So the area of the largest rectangle that can be inscribed in the ellipse is 24. The trough in the figure is to be made to the dimensions shown. Only the angle theta can be varied. What value of theta will maximize the trough's volume? Okay, so we have this trough. I just recreated the trapezoid over here and labeled this side S. So we can define S as 1 plus sine theta plus sine theta. We got 1 because we know this is 1, so therefore this length over here has to be 1. And then sine theta and sine theta are just here, these lengths over here, because sine theta. And yeah, so then we can simplify that down to 1 plus 2 sine theta. Okay, and we know the height is cosine theta because that cosine theta. So the area of the trapezoid would be the addition of the two bases divided by 2 multiplied by the height. So we have 1 plus 2 sine theta, all over divided by 2 times cosine theta. This you can simplify down to 2 times 1 plus sine theta over 2 times cosine theta, which then we get cosine theta plus sine theta times cosine theta. Okay? And And then to find the volume of the trough, we need to multiply the area of the trapezoid found here by 20, because that's the length. So we have cosine theta plus sine theta times cosine theta times 20. This is just equal to 20 cosine theta plus 10 times 2 sine cosine theta. We did this over here so that we can simplify the inside to 10 sine 2 theta. So 20 cosine theta plus 10 sine 2 theta. We can take the derivative of that function. We get negative 20 sine theta plus 10 cosine 2 theta times 2, which is just 20 cosine theta minus 20 sine theta. Then we can graph this and put on our sign chart. We found the critical value you just find from your calculator. It would be pi over 6. And the range is from 0 to pi over 2. Because as you can see here, if theta is 0, you just have a box. And then if theta is pi over 2, it's just a line. So that's the balance, alright? So at pi over 6, we have a maximum. Because before that, it's positive. And then after that, the derivative is negative. Okay? So we know that at theta equals pi over 6, that would be the maximum trough's volume.
Epic rap battles of WWE! Optimus Prime versus Megatron! Begin. My last name's Prime cause I split you up like factorization. I'll make this fast cause I just did that optimization. I don't even know why you are hating. I'm the best transformer ever, no debating. If you mess with me, I'll put you in the hospital. You're the reason Transformers 1's unwatchable. You differentiate, I integrate, I accumulate like a water rate. They call you Megatron, but you ain't Mega. I'm a PS4, and you're a Sega. Megatron. Name is Megatron, and I spit them chocolate bars. I refuse to be beat by some talking car. You say you're hard, but you're soft like toffee. I could end your life by spilling my coffee. I roll solo while you rockin' rabbit posses. I'm the OG gangsta bot, you're a copy. All your bars were whack, you need to stop cheesing. I'm cold like polar, you're square like Cartesian. Optimus Prime. I don't need calculus to see that you're an abomination. I'm the exact value, you're an approximation. All I eat is prime rib, you're all like Macedon. The only prime you get is Amazon. I'm not playing around, Mr. Megatron. You're gonna stay in the finals and I'm LeBron. You're gonna choke, I'll push you to the limit. This battle is like Centennial Prime cause I killed you. You killed it, don't make me laugh. I'll make you discontinuous like a piecewise craft. I'm a narcissistic bot, but I'll say this humbly. I'm not the one with a friend named Bumblebee. There's a reason they call us Decepticons. I'll have you running in circles like a limicon. I'm gonna end this battle, I guess you're out of luck. Tell Megan Fox I said her nose job sucks.